In this section, we're going to completely change gears and start talking about what's known as polar coordinates. So if you think back to when we talked about vectors, one of the ways we could discuss vectors was by talking about the direction and magnitude of that vector. Polar coordinates are actually based on something very similar. So if we're discussing a polar coordinate, it's going to take the form r, theta. So r is the distance from the origin, you can think of that as magnitude, and theta is the angle, and that's just the same as the angle from a vector. Okay, so instead of talking about x, y, we'll talk about r, theta. Now we have kind of a long drawn out mathy definition here, but it's exactly what I just described, a distance from the origin and an angle. So to help us get a little bit more comfortable with this, we're going to start by just plotting a few polar coordinates. So let's start with this first one. Remember the order is r, theta. So this is telling me it's a distance of 2, and the angle is pi over 3. So sometimes when we're sketching a polar curve, we'll have a polar grid. So instead of a rectangular grid, you can see it's moving around in a circle, right? It tells you what the angles are as you move around, and you can also see the distance from the center with these concentric circles going out. So I want to think about an angle of pi over 3, that's this line, and a distance of 2. That would put me right there. Okay, so that's part A. Okay, part B is a little bit weird. Okay, so notice this has a negative angle. So if you have a negative angle, it's exactly what you'd think based on negative angles from the rest of the course. Instead of moving in the counterclockwise direction, we'll move in the clockwise direction. So negative pi over 6 and a distance of 3, that puts us right there. Alright, I want you guys to go ahead and pause, see if you can sketch what 3, 11 pi over 6 would look like. So a distance of 3, that's going to be on this outer circle, an angle of 11 pi over 6. This is our first example of seeing two different points that can be described differently. Right? So it's the same spot on the graph, it's just two different descriptions. Okay, and it turns out there's often, well, always, infinitely many ways you could describe any particular point. Okay, so the way we phrase our points is not necessarily going to be unique in terms of what spot it describes. So that's what our next bullet point is, right? It just says polar coordinates are not unique. Now, what I've written here is kind of complicated looking. Right, it's going to say, here's some general ways to describe a single spot. I don't recommend memorizing this. Is it technically true? Yes. Here's how I'd like you to think of it instead. Instead of memorizing these weird formulas, let's just say if you have a point r, theta, the way you can come up with more descriptions of that same spot is just by increasing the angle by pi and deciding if we need the same distance or a negative distance. Okay, so it's worth discussing what does it mean to have a negative distance for polar coordinates. Well, think back to the ones we had before. When we did 2, pi over 3, that was a distance of 2 in the direction of pi over 3. Just like when you have a negative number multiplied by a vector, it makes it go in the opposite direction. A negative radius, or a negative value of r, tells you to go in the opposite direction. So if I had had negative 2 pi over 3, then instead of going in the direction of pi over 3, I would go the opposite direction, a distance of 2. That would be this guy right here. Okay, so the idea is if you add pi, you go in the opposite direction. If you add 2 pi, you go back in the same direction. And you can keep adding pi over and over again and coming up with more descriptions. So let's try this one really quick. We've got the point 3, negative 3 pi over 4. Right, so an angle of negative 3 pi over 4, a distance of 3. And we're supposed to find 3 other polar representations of that point. Okay, so let's first try adding pi. Right, if I add pi to that angle, I would get pi over 4. So something, pi over 4. And if I'm thinking about pi over 4, that's in that direction. If I just said 3, that would be going the wrong way. So I want to do instead negative 3. So here's another way I could describe that point. I want you guys to come up with 2 others, right? So keep on adding pi to that angle and think about should it be a positive 3 or a negative 3. Then unpause and see if we came up with the same stuff. So our next one, if I add pi, that's an angle of 5 pi over 4. That's right back in the same direction, so I just want a radius of 3. And if I add pi again, that would be 9 pi over 4. So I've done a full revolution and then an extra pi over 4. That's in exactly the wrong direction, so I need to make it negative. Okay, so these are not the only solutions we could have come up with. There's tons of different solutions, right? Whether we added pi like we did, we could have subtracted pi from that guy and come up with other angles. Lots of different ways to describe any one specific point.